Hello and welcome to what will probably be the last free version of the Siemens S7 Odyssey series. From here on out, I will be creating more videos and making them available in a different way. But be assured that this series will continue. I will be putting lots of other interesting content in the program, and it will grow as I come up with new concepts. This continues the drive control series with the simulated encoder, and I will be finishing that series up in this video. So I hope you enjoy it. Thank you. This is a good time to review the entire project. This is a list of all of the OBs, FCs, DBs, and UDTs we've created so far. You can see that I am looking at this in detail view, so I can see the names of everything. That is a nice way to look at things. You can see all the sizes of everything, what things are. Here is the call structure for all these routines. OB1 is the main organization block that calls everything. FC1 is the system routine that handles all of the modes. FC2 is inputs. We didn't use it for this drive series. FC3 was our first sequence that we built with the pick and place in some of the earlier videos. FC4 is sequence 2, which is where we did this drive axis move logic to start and stop the drive. I have added a sequence in here that I'll explain a little bit later. FC5 was the outputs. The outputs usually take the physical outputs, and they're driven by auto and manual mode instructions. FC6 is faults. We will be getting to those later. And FC20 is where we put most of our simulation logic, including FB10. And FB10 was the axis drive simulation that we did in the last two videos. So we got things to where the axis could move forward and reverse and give us the output speed and give us the output encoder counts. Then we're going to do some experimentation with that using this variable table and this simulator. You can see all the different things we can look at in the variable table, and we can start and stop things in the simulator. So this is kind of where we were when we finished up the last video. Since the last video, here's what I have done. I created a sequence here, and I don't know how many people knew about these little tabs over here. Of course, this is the programming elements. This is the organization of the program, and this next part here actually shows the network comments that you put on here. They're actually not the comments, they are the network titles, and so it acts sort of as a table of contents. So in this rung, network 5, I started an x-axis move sequence starting with a push button, which we will activate right here in the simulator, and that moves a 10 into the sequence. When there is a 10 in the sequence and the encoder position hits 5,000, then we move a 20 into the sequence. Then down here, when there is a 20 in the sequence and the speed goes to 0, then we move a 0 back into the sequence. So a very simple sequence that we are going to modify in just a few minutes here. And then I put a summary underneath the sequence. This is typical of the way that I usually program auto sequences, and it's common in what's done in industry. The auto run command in step 10 is active, and then the auto stop command is active in step 20. So those are the two things that make the actuator move. Back here at the top of sequence 2 was where I did my start and stop commands for the simulated drive. Typically these would be in the outputs routine, but I haven't moved them there yet. I will move them there a little bit later when I do more organization. You can kind of see how this program organically grows. We make changes as we go along and then put things in their proper places. So this is another thing that's typical. Usually you will have one command that is active in manual mode, you'll have another one that is active in auto mode. And you would also want to integrate that with the auto cycle bit, which I have not done here yet. We're just going to run this in auto and manual. And let's go ahead and run a simulation. And you'll see here we are starting at encoder position 0, and I'm going forward. And if I am in auto mode and I press the move button, you can see we are moving up, and when we hit 5,000 for encoder position, we are going to issue the stop command. You will see this quickly ramp down. And what happened was we issued the stop command at 5,000, and it took 280 counts for it to stop. And that was, of course, based on the deceleration here that we had programmed. If I change the deceleration to, say, 7, and we'll go ahead and write that in there. Okay, I'm going to reset the position. Now normally, of course, I would move back to the 0 position. 0 would be an absolute position. But in this case, I'm simply going to set the home position again, which puts us back at 0, and then I can do another move. So we've set home. Our sequence should be back at 0. And this time, we go up to 1400. And we seem to not be moving here. Okay, that's because I'm holding the set home active. There we go. So we're moving forward. This time, since we have a little sharper deceleration, we should end up stopping a little bit sooner. Now 230, so that's a little bit quicker than the 280 we had before. So I'm also going to show you a graphic here that explains this a little bit better. Now this is a graphic of speed versus position, and you can see here if I change my acceleration, that's what this lower Accel and Decel marks are. If I change my acceleration, it takes me longer to get up to my preset speed. This is where I issued my stop command. So if I wanted to stop here, I would need to issue the stop command earlier. And I would be pretty much guessing as to exactly where I wanted to issue the stop command. So a better way to do this, rather than putting a fixed value in here, of course this needs to work for every speed, would be to issue a preset speed command, go down to say 10%, and then creep up to our desired stop position. And if I issue the stop command here, I will have a much better chance of hitting my desired stop position. Once again, this is a VFD. A servo would do this automatically. It would know where it needs to stop, and it would issue the stop command in the proper position and decelerate down to the exact position. But with a VFD and an encoder, you're kind of having to guess where you want to be. So by using the preset speeds, and that's what we'll be doing next, here is the preset speeds that I've put in here. So what I'm going to do is modify the sequence to use the 80% speed when we're running, and then change the preset and lower the speed down to 10% deceleration down to that, and then issue the stop command, and we're going to see how far past the desired position we end up. Okay, I'm back after some modifications here. What I did is added another step. You can see here, start x-axis move sequence. I added a step 15, which is running at slow speed. That is the preset. So in step 10, we run at 80%. Then we say that when the encoder position hits 4,500, which is a little bit before the 5,000 stop point, we move a 15 into the sequence. Then while we're at 15, when we hit 5,000, we go to 20 and we pass out our stop command. So in the summary here, step 10 is the same. In step 15, I moved the preset speed into the command speed percentage, and I also did have to set a flag to tell that we were in deceleration. So this was something that I hadn't anticipated in here, right? Decrease the speed when in deceleration. So I had it only decreasing the speed when the stop was not active. So this needed to be added to our simulation. When not in step 15, then we move the regular speed, preset speed 2, into the command speed percentage. And of course, those can be modified right here. I added preset speed 1, which is what we're doing in step 15, and preset speed 2, which is our regular run speed, and I put this in step 10. So that is the way this runs, and of course we still stop in step 20. So let's go ahead and run this, and you'll see how much quicker this stops. So I've already set my home position. I'll do a move. You can see it ramps up to full speed pretty quickly. When we hit our 4500, you will see this command speed percentage go down to 10. And you can see the actual speed is quite slow here. And then we stop. And you can see here before, we were stopping at like 5,280, 5,230, that area, just by changing the decel. But now we're stopping at 5,008, which could be considered to be in the range that we want to stop at. I'd say 10 encoder counts, something like that, plus or minus 10 encoder counts. So this is from issuing the stop command right at 5,000. You can see that we only went 8 ticks beyond it. So that's the way this works. We'll bring back this little diagram here. So by creeping up to our stop position, you can see we stopped just after the correct stop, the desired stop position. So if we had made this the stop position, we would have been just past it, and of course we would have gone 280 or so past it if we stopped from 80%. So there's a big difference between stopping at 80% speed and stopping at 10% speed, and that is the entire reason for putting this preset in here. By using presets, you can use digital inputs actually to fire the presets. I moved the 10% and the 80% in here into the register, but you can just use a digital input to select the preset speed on the physical drive itself. So that's another method of controlling speed to do your creep to a stop. Hope you enjoyed this series. It took 3 videos to complete the explanation of this regular VFD versus encoder stopping sequence, but if you learned something from it, then it was worth it. Thank you very much.